first one. Very first one. So it's right up, so like, here's number 1. Pencil. Pencil. 5, 6, 7. Right? So you write all the way down to 10. So 1 through 10. There's 10. It's called a flip book.
I wonder what it could be.
Okay, so at the top where it says number 1, on this top thing, right where the staples are, you're going to write solving multi-step equations and inequalities. So each of these is going to be a potential step that you would need to solve an equation. Like I said before, some of these you won't need, some of them you will. Depends on the type of equation you're given to solve. Okay, so then what you're going to do is you're going to flip this up. It said solving multi-step equations and inequalities.
That's a big word.
Okay, so then you flip this up. And now on this part that we just flipped up, on the back of this, so not down here, but up here. Everybody with me? Put your hand where you're going to write. Cover up where you're going to write. So Landon, flip it open, please. Okay. You're going to write out this extreme equation that we're going to solve together.
Wait, are we writing our 2 on 1?
Just a second.
What? Wait, how does
Write that out. So you're going to flip this up.
I can do that later.
We're writing up here at the top.
Oh,
Okay.
well, there's some big numbers.
Right? So we've got fraction, we've got distributive property, we've got all
I don't
sorts
like
of fun
this.
things.
Oh, you're gonna love it.
No. Extreme example is from this right up here. Yep.
Is it 3, 2, or 3x?
Is it 3 to the x? What's 3x?
I did this problem. I haven't even written it down.
Okay.
You did?
Matthew, are you okay today?
Yeah.
Okay. Read it a little bit. Nope, you're good. You wrote it up at the top. You're good. Matthew, where are you right? Nope. It's supposed to be written up here.
Oh, okay.
Yep. This is an X. There we go. Okay. Now, next to number 2, we're going to write distributive property. Nope, leave it up. We're just going to keep flipping and adding things. Yep.
Wait, what do you write?
Distributive property.
Let's see if Jake said
Still just using our regular pencil. I'll tell you, you'll know when to use red because I will use red. Yes. Okay, just wait 1 second and you'll be able to see it in a second. Okay, so now we're still on this section here where it says distributive property. We're going to write use the distributive property Nope, we're still on the same thing right here where it says distributive property. We're still on this same page here. To eliminate the parentheses. We're going to be rewriting a lot of things as we show each step. So there you can see the equation again, Matthew.
We rewrite it.
Yep, rewrite the equation, and then we're going to actually show what the distributive property looks like. Yep, sharpen my pencil. Sure. Okay, does everybody have this written down? So now we're going to show the distributive property. Okay, some of you are not following along. You're not being respectful. I get it, it's the first day back after break, but we still have work to do. So remember, distributing is where we multiply what's on the outside of the parentheses times what's inside the parentheses. Okay, it's a multiplication problem. We're still here on this 2 page, where you see the number 2, distributive property. Notice that I'm using red now.
Oh.
Okay, so remember this is like multiplication. So 1/2 times x is going to give me 1/2 x. 1/2 times 4. So what's half of 4?
2.
It's going to be 2. And then I don't do anything with the 3x. It just stays where it is because it's not part of the parentheses. Nothing's being done to it. Nope, I'm just getting rid of the parentheses. 2/3 times x is 2/3 x. And then 2/3 times -6. So what I wrote over here on the board, this is like saying 2/3 times -6/1, right? So then I get 2 times -6 is -12, right? Because you multiply across the top. 3 times 1 is 3, and then when you simplify them, you're going to get a -4. Yeah. Yep. So 2/3 times -6 gives me -4. And then I just have to put this 2 here because it's just part of the original equation. So that was the distributive property. We distributed, we got our new values, we brought down some old values. For our third tab, we're going to write clear fractions. Don't flip anything yet, just write clear fractions on that where it says number 3. Okay, so now we're going to flip, and we're going to write up here on the top. So everybody put your hand up here on the top where you're going to write. So flip the page, and we're going to write up here on the top. Matthew, you with me? Okay. Up on the top. So down here it says clear fractions. We're not going to write here yet. We're going to write up here at the top. So step 1 for clearing the fractions is to multiply each term by the least common denominator. And step 2 is to simplify each term. Coming around, making sure everybody's writing it in the correct place. Because it can get pretty ugly when you're adding and subtracting and multiplying and dividing by fractions with whole numbers. It just gets nasty. So we clear them. We do something to eliminate them from our equation to make our equation solving easier. So I'm now going to go down here where it says clear fractions, right? I'm going to rewrite where I left off, 1/2 x plus 2 plus 3x equals 2/3 x minus 4 plus 2. Right, so I'm showing each step, and I just keep rewriting where I left off so you can see the new step that I did. So if we were going to add 1/2 and 2/3, we would need a common denominator, right? What would my common denominator be? My least common denominator for 2 and 3, because those are my denominators. 6. Yeah, because 2 goes into 6 evenly, 3 goes into 6 evenly. There are other numbers that those go into, but we're looking for the smallest one, right? So our least common denominator equals 6. And I only look at the fractions, right? What if I only have one fraction? What's going to be my least common denominator?
The denominator of that.
The only one that's there. Exactly. So step 1 says multiply each term by the least common denominator, right? So this is going to look really messy. Don't let it scare you, but it's going to look kind of messy. So here's step 1. Notice I have my red pencil. 1/2 times 6 over 1x, because then I'm multiplying 1/2 by the 6, plus 2 times the 6, plus 3x times the 6. Everything gets multiplied by the 6.
Punch it in a calculator.
Punch what into a calculator?
Problem.
So when it comes time for you to prove to me you know how to do this, you won't have a calculator. Yep. Also, when you have like thirds, those are not exact values.
Is that a 2?
Where?
Right after 6 over 1.
X. Yep. So when you have thirds, Max, those are not exact values. So you would get something like 0.666, and if you don't use the exact value, your answer is going to be just a little bit off. So we just get rid of the fraction so everything's an exact value. So that was step 1. We multiplied everything by 6. Step 2 is to simplify each term. So let's look at 1/2 times 6 over 1. What's 1 times 6? What's 2 times 1? So what's 6 over 2? 3. So I have 3x. Right, because I multiplied these two and I simplified them, I got 3x. What's 2 times 6? 12. Easy. What's 3x times 6? How many x's am I going to have? 18x. All right, moving right along. See, we're getting rid of these fractions so we can have an easy peasy equation. 2 times 6 is, 3 times 1 is, 12 over 3 gives me 4x. Negative 4 times 6 is negative 24. 2 times 6 is 12. Right? So now we have no fractions. We have no parentheses. We're on a roll. Everybody still with me? I didn't lose anybody off the hayride, right? Nobody fell off the back? You guys know what I'm talking about? Okay. The next one is clear decimals, which some of you might be thinking, we don't have any decimals, so we're not going to put anything on this page because I don't want to confuse you with going off track of this equation we keep building on. So after you write clear decimals, you're going to open this up, and right above it we're going to write no decimals to clear.
On the top part or in the big box?
In the big box right on this same thing. Yep. So we will practice clearing decimals a different way because we don't have decimals in this equation. You can't have decimals and fractions and make it all work, so we'll come back to that. So then under that, on this fifth flap, we're going to write combine like terms. Do you guys remember combining like terms before break? When we did all the color coding?
Oh yeah.
Right? We looked, what is the thing that, what do like terms have to have? Who remembers?
Oh,
Emma?
like the same, like positive or negative, like x's and y's and stuff like that. Like they have to match.
The variables have to match, right? What else has to match in order for you to be able to combine them? The negatives and positives don't matter, but something else does. It's a tiny little number. That's exponents, right? So you have to have the same variable and the same exponent if you want to combine them. Okay, so let's flip this. And now I'm up here at the top. Putting my hand up here at the top, ready to go. Check on your neighbor, make sure they're writing in the right correct spot. Combine like terms on each side of the equation. Before solving. Yep. This is on the top part above. Combine like terms on each side of the equation before solving. Sometimes students go into solve mode. Then they have all these random combining like terms that they could have done first. It's almost needing like 2 seconds until we're done. Because we have this is the last one we're going to do. Okay, so we're going to write out the equation where we left off. So now I'm down here on the big section here. I left off at 3x plus 12 plus 18x equals 4x minus 24 plus 12. Right, so this is where we left off after our clearing the fractions. We're going to draw our wall of equality.
Oh.
We're going to label left and right.
Is that 24?
It's minus 24 plus 12, yes.
Looks like a Y.
Here, I'll fix it. Is that better? Okay. So what are my like terms on the left side of my equation? What can I combine on the left side? What two terms? Max?
3x and 18x.
Yep, 3x and 18x. I'm not using inverse operations yet. They're on the same side, so I'm just going to add them, and I'm going to get 21x. And then I bring down the plus 12, because it's still part of the equation. I don't start adding or subtracting or doing those opposites until I'm ready to cross this wall of equality. I'm not ready to do that yet. What are my like terms on the right side? What are they? Emma?
Negative 24 plus 12.
Yep. My constants are my like terms here. So now I have 4x minus 12 because negative 24 plus 12 is going to be a negative 12. All right, we're going to stop there for today. We will finish this flip book, this amazing resource tomorrow.
This is a great resource.
Do you want us to